Hi everyone, my name is Teshwar Naidu. I'm studying BTech CSC in Lovely Professional University. Welcome to today's presentation on Cred ER diagram. Have you ever wondered how apps like Cred manage all the credit card information and the transactions? Well, it's all thanks to the something known as ER diagrams, which stands for Entity Relationship Diagrams. And in the case of Cred, they got a special version called as Cred AR diagram. So, like, if you want to know about what is exactly this diagram means, it's simply about a map that shows how different parts of Cred app are connected. Imagine you are planning a road trip and you use a map to see all the roads, highways that leads to your destination. The Cred ER diagram does something similar but for the app's data. In the Cred app, there are different things or entities like users, credit cards, payments, rewards, stores, merchants, things like that. These entities are like puzzle pieces that fits together to make the app work smoothly, perfect. And the diagram shows how these pieces related to each other. For example, it might show that a user can have one or more credit cards linked to their account, or that a payment is connected to a specific credit card. Understanding the credit ER diagram helps people how to design and manage the app to keep everything organized and running smoothly. It's like having a blueprint of a house. It shows where everything goes and how it all fits together. In this presentation, we will take a closer look at the different parts of credit ER diagram and see how they work together. So let's dive into the explore the fascinating world of credit ER diagram. If we look further in ER diagram, there are a few main things we look at. And the first one is entity. So these things like the main characteristics or objects in our app or system. In case of cred, entities could be users, credit cards, payments, and rewards. Think of them like key pieces of puzzle that make the app work. Like we can represent attribute. If you see here, a rectangle, or we can also use rounded rectangle which says same thing. So this is how we represent entities, and if we go further it's about attributes. So attributes are like the characteristics or details of each entity. For example, for the user entity, if we consider the user entity, like attributes could be something like name, user ID, email, phone number, these details. These are some of the attributes of user entity. So these details help us to understand more about the entities. Like so we can represent attributes using this oval shaped things. So this is how we represent attributes. There are some types in entities and attributes. So this is how we use. So this is a weak entity, and if you go further, this is a key attribute. So key attributes. So key attributes are the things like which are unique, and which is the main thing for the entity. So for example, if you take user, in the user, we the main entity, the main attribute, the key attribute is, of course, it's user ID, which is unique for each user. And if you go further, so this is derived attribute. So this is how we represent a derived attribute with a dotted oval shape. So derived attribute is something that we derive from another attribute. Example, you can take age. So from using date of birth from another entity's attribute, we will derive the age. So this is how we represent derived attribute. So if you go further, there is a multi-valued attribute. So multi-valued attribute is something which have multiple values in in particular attribute. Example, we can take as address in user. If you take user entity, there will be some slot as address. In address, if you observe, there can be two, three parts like the village name, the city name, and the state name, country. So these are like it has multiple values. If you want, so we can get it what we want from it. And if we go further, so these are the things which are important and which we discuss in this presentation. So So now it's about relationships. Relationships show how entities are connected or linked to each other. For instance, in the Cred app, user can connect it to one or more credit cards. This connection shows us relationship in the diagram. Uh, there are types in the relationship. It can be one to one, it can be one to many, it can be many to one, or many to many. So these are the relationships. We will represent one to one using this, and one to many using this, and many to many using this. So these are the common three relationships which we can observe in our credit ER diagram. So if we go further, so normally we will represent a relationship in diamond box. So this is how we represent a relationship between some entities. You can take like for example, if you take some two entities, take some two entities. So if we take user and the credit card. So in credit app, so user is related to credit app by user paying. So user pays using credit card. So there is also another relationship, user and transaction. So user makes a transaction. So we can write makes in this. So user makes transaction. So this is how we will write and how we will represent the relationship between the between some entities. So if you go further to draw the ER diagram, first I'm gonna start with um, yeah, I'm going to start with user. So I will create an entity named as user. So I took a rectangle box you can see here. So I will name it as users. So this is our first entity, which is most common and important entity. So this is user entity, and from here I will connect it with four attributes. So as I mentioned before, attributes are represented in oval shape. So you can see I'm taking attribute. So I will name first attribute as, so this is a normal attribute, but as I want to represent a key attribute, I'm taking an oval shaped thing which with an underline. So this thing represents a key attribute. So key attribute can be user ID. So this is unique and unique for each user, and which is important to users entity. So the second one can be users name. I can write in the lowercase, but I prefer uppercase. So for the third entity, we can uh, save some email. We can save some email, and if we go further, just a second, yeah, if we go further, the fourth one, the last attribute of users can be phone number. I will write as info queries. You can also this is the normal attribute. You can also use multi-valued because user can use two, three phone numbers, but as in Cred, user can only use the Cred app with one phone number. So I'm using a normal attribute. So as I want to connect it with user, can easily connect it like this. So this is how we draw the diagram. So as you can see, I connected. So this is a small diagram, a part of totally a diagram. So you can see here, this is an entity, users entity, and these are the attributes. This is a key attribute. As you can see, it's underlined and it's in the oval shape. So this is a key attribute which is unique, and this is the second attribute, third, fourth. So these are the attributes. We can, if you go further, we can create another one as credit cards for the. We can create another entity for credit cards. So I'm using another rectangular box and I will name it as I will name it as credit credit cards. So if you go further, the attributes that could be in this credit cards entity is credit card ID, user ID. User ID you can get it from here. User ID, credit score, credit card score, or you can also use payment. So these are the things which we need to include in this credit cards entity. So I will use the key attribute here. So which gonna represent credit card ID. So this is credit card ID. And if you go further, the second entity can be user ID. And third one can be credit score. So credit score is normally used. So using credit score, we can organize the things more easily, and we can also get rewards in this Cred app. So this is one of the important entity in our Cred app. So if you go for the last one, payment. So these are the attributes in our entity, credit card. So I'm gonna connect with just a second. So this is how we need to connect the things. So you can see here, I'm representing two entities, users and the credit card, and both have each key attribute for themselves. And now I'm going to represent a relationship between them. So as I told before, relationship is represented using a diamond shaped box. So this is how we represent a relationship. So as the relationship, in simple words, user pays for the credit cards. It's he can pay for the subscription things. So after this, okay. So basically, we need to figure it out that whether the relationship between the credit card and users is one to one or one to many or many to many. So if we think users can have multiple credit cards, like one user can have multiple credit cards. So it's the relationship is one to many. As I mentioned before, one to many can be represented using another listing. So, yeah, so this is one to many. So this is how we represent. So this side represents many, and this side represents one. So one user can have multiple credit cards. So I will connect these two things, these two entities. This is how it's connected already. So the relationship between both, yeah, you can see here, user pays for credit cards. So this is the relationship between the user's entity and the credit card entity. If you go further, making the third entity. So third entity can be transaction. So I'm trying to make third entity as transaction. So this is how we make. I'm taking a rectangular box which represents entity, and I'm writing. transaction. So yeah, I can write transaction or transactions. I'll prefer transaction. So for the transaction, um, the attributes could be a transaction ID, user ID, and amount and date. So these four are the attributes of transaction. There can be many, but for now I'm taking four attributes. So the key attribute can be transaction ID. So I'm giving here. So it's transaction. So it's a transaction ID. And the second attribute, as I told, it's user ID. So, and if you go for the third could be amount. And the fourth one is date. So for date, it can be multi-valued because we will store the like, we can exactly store the date and time exactly in one singular column. Like we can use derived for that. Okay, multi-valued. Sorry, my bad. Multi-valued for that. So in the multi-valued, we can store date and time. So I'm storing date and time in one attribute. So this is for space complexity. Moving further, so this is how we connect the things. Yeah, it's connected. So we can see three. You can see three entities here. One is users, one is credit cards, and one is transaction. So three are at the part of ER diagram of Cred app. So if you go further, there is a relationship between the transaction and user. So transaction is something like user makes. So we will try to make a relationship. Basically, one user can have many transactions. So we can make it as one to many. So I'm taking one to many. So I'm connecting it. I will, so using these arrangements, we can flip it, we can reverse it. Those are the things we can use this arrange thing here. So I want to flip it. Is it good? No. Yeah. So I'm connecting this single line to users and multi-line one to transaction. And yeah, think it's fine now. Yeah. Now it's fine. As I connected users and transactions with a one-to-many relationship, now we need to show the relationship using a square column, square shaped thing, a diamond shaped thing. So users makes transactions. So we're gonna write makes in this diamond box. So we need to keep that in the middle. This shows the relationship between the user and the transaction. If we go further, we can also make an entity named as merchant. So merchant are the guys who maintain stores, who like, sell the products in our Cred app. So the entity of merchant. can be created using the same process. We will take a square bracket. We will rename it as merchant. So you can see I created a entity here named as merchant. Now I will take a key attribute. So the attributes in merchant entity could be merchant ID, name, the category, which category he belongs to, and the address of the merchant, which is a multi-valued as I discussed before. So you can see, uh, let me zoom it. Yeah. So I will write it as merchant ID, which is primary thing to a merchant attribute, merchant entity. So we go further. The second entity could be the name of the merchant. I will just write simple as name. And the third one could be the category where the merchant belongs to. Need to categorize the things up. So, and the last one could be address. So address is a multi-valued because um, it can have the street name, the city name, the state, the country. So it is a multi-valued attribute. So we represent in two oval shapes. So I will rename it as address. So now I need to connect this up. I want to follow I want to follow a particular pattern when I was when I'm trying to represent this. Hmm, yeah, it looks more better now. So the relations between the transaction and the merchant will be same as user and the transaction. So it will be one to many because one merchant can maintain multiple transaction between the user. So it could be the one to many relationship. So I will take the same thing as I took before. So now I'll connect the single line with with merchant and the okay, yeah. So now you can see the relationship between the merchant and the transaction. So now I'm using a diamond box to represent the relationship between transaction and the merchant. Yeah. So basically the transactions are directed to merchant. So I will just write a directed. We can be more formal with it. Example, mm, the reason for the transaction is user purchases something, so we can also write purchase in those terms. But to be simple, we can just write the user makes transactions and transactions are just directed to merchant. Similarly, with user pays credit cards. So if we go further, the third one, okay, the next entity could be the store. We can go for the product. The next entity could be the product. So we need to rename this rectangular box as product. So the attributes that could be present in this entity is product ID, the user ID who want to buy this or who added to the cart, or it can be and it can be store ID where the product belongs and the amount, the price of the product exactly if we speak. And to move further, we're taking a key attribute as product ID. Mm, yeah, we keep here. Hmm. So I will rename this as product ID. And the next one, it's a simple key, simple attribute. It's user ID, the user who headed to the cart or who wants to buy this product. And the third one is the store ID. And we gonna make the store entity too after this. So it's store ID. And if we move further, the last entity and the last attribute of this entity could be the amount or whatever the price of the product. So we need to connect them. Yeah. If we move on, the relationship between the user and the product can be one to many because one user can buy multiple products. As it's specified with product ID, one exactly one product with similar use product ID cannot be brought by multiple users or so it can't be many to many because we are specifying the product ID. So one product with one particular product ID can be sold to one particular customer. So only one customer can buy multiple products. So it's one to many. So we are using one to many thing to represent this thing. So to reverse it, oh, yeah, I'm representing now. We further need to represent the relationship between them using a diamond box. So I can name it as like user buys the product. So I will just I will write it as buys. User buys the product. And if we go further, as I said, we're going to create another entity named as store, which will have the direct relationship between the product and the merchant who organized the store. Yeah. So if we want to write about this, it's about the store. So the attributes that can be present in the store entity are the store ID, the merchant ID, who gonna organize the store, and it could be the user ID and the transaction ID. transaction ID is like from the transaction entity from merchant ID. Merchant ID is from merchant ID and merchant entity, and so on. So we're going to represent the store ID using a key attribute. It's almost done. So the attributes can be store ID, and the next one can be merchant ID. The next one can be user ID, and the last one can be transaction ID. So this is the entity of store, and the relationship between the product and the store. We are that that's a simple thing. The store one store can has multiple products, but one product with a particular product ID cannot be in multiple stores. So use one to many here also, a similar thing. So product belongs to the multiple section and store belongs to single one. So I want to make it reverse, exactly reverse. Hmm, think I can manage. Yeah, yeah. Now it's fine. And the relationship can be represented using a diamond bracket as we can see the product is the relationship between the product and the store is the availability in the store. So you can just write product is available in the store. So I will just write available here. And the relationship between the store and the merchant, like similar to like merchant can have multiple stores. So it's like one too many. It's also similar because one store can also have multiple merchants. That is similar. So we can use one to many or we can also use many to many. I will go with many to many here because one store can have multiple merchants organizing it. So I will go for many to many. You can also go for one to many. It depends. There is no ideal case for this. So these are the entities, and I want to add one more entity to this. It's loan. You can get loans from Cred app. So I'm going to represent an entity named as Cred loans. So I will create here. So to be familiar, yeah, I think I will go here. So I'm taking a rectangle box here, or I will go here. Yeah, I'll go here. To be quick, so the entity can be renamed as loan. The loan entity could have the loan ID, user ID, the amount, and also the date, the issuing date. So I will start with the key attribute. Of course, it's loan ID. If we go further, you're going with simple. attributes, user one, and the amount, and the last one is date and time. Date and time can be multi-valued. It's not specified exactly. As I mentioned here, you can also similarly mention here, but for this time I will use simple attribute as date. It's time to connect everything. Yeah. So things are connected. So this is the entity of loan, which have four attributes. One is the key attribute, loan ID, and the remaining three are simple attributes named as user ID, amount, and the date. And date can be multi-valued, as I said before, and I also used it in the transaction entity. And if you go further, the relationship between the user and the loan can be one to many because one user can take multiple loans, but the things are simple, but one loan cannot be issued to multiple users. So it's like one to many. So I'm gonna use the notation for one to many. So we'll connect the yeah. You can see this. So this is the relationship between the users entity and the loan entity, which is one to many. And if we discuss about the relationship between the users and the loan, it's simply as user financing the loan, or you can just in the simple English you can write user takes the loan, user gets the loan, anything. It's about uh, so I will just write user takes here. So user takes the loan. So this is the PR diagram of Cred. You can see here. Just copy this. Yeah, get it here. My bad. Okay, you can see here. So if we go for the overview, we started with the user entity. So we started with the user entity, which have four attributes. The key one is user ID, and the remaining three are simple attributes as username, email, and phone number. You can keep the phone number in the multi-valued if you have two or more than one phone number. And the second one, we made an credit card entity, uh, which has which has credit card ID as its key attribute, and the remaining three are user ID, credit score, payment, and those things. It depends upon the app. So if you go further, the relationship between the users entity and the credit card entity is easy. It's one to many, as I said before. One user can have multiple credit cards and he can link multiple credit cards to a credit app. And the third entity, as we draw here, is transaction entity. You can see here transaction entity has transaction ID as key attribute, and remaining three are user ID, amount, and date and time as date and time. This is a multi-valued, as I mentioned, the date and time. You can derive the things up, like you can separate the things as date and time. So, and the relationship between the user and transaction is that user makes the transaction. So I made it simple. And this next one is merchant. You can see here merchant. Merchant have four attributes. The key attribute is merchant ID. The three are normal, and the last one, the address, is multi-valued, as I discussed more than once. So is that address can have multiple values as city name, the state and the country. So it depends upon the attribute. It's a multi-valued attribute. And the next one is, yeah, product. So product is something the user buys through Cred app. So I made a relationship between the user and the product. It's one to many, as user buys multiple products. You can see which has a significant product ID. So product ID has four attributes. The key attribute is product ID, and the remaining three are user ID, store ID, and amount. And the next entity I created is store. The store, the store is something the products are stored in, like products which are available in the store. So the product has a direct connection with the store, as I is shown here, availability. And the store has four attributes. The key attribute is store ID, and the remaining three are also IDs, which are merchant ID, user ID, and the transaction ID. And the relationship between the store and the merchant is many to many, because one store can be organized by multiple merchant, and one merchant can have multiple stores. So I mentioned multiple, one to many. So I forgot to mention the relationship. So I can simply write maintain. So merchant maintains the store in a simple way. So if we go further, I created a loan entity. So basically, loans are like users can finance some loans in Cred app. So I mentioned the loan entity. In loan entity, you can see that loan ID is the key attribute, and the remaining three are user ID, amount, and date. Date can be stored in the multi-valued if we specify uh, the classic one, the primary one. And the relationship between the loan and the user is uh, one to many, as one user can finance multiple loans. So this is our uh, great ER diagram. So we can style this. We can style using colors to be more interactive. I think all are fine. Yes. So you can see here. So we have multiple entities in our Cred app. So with these things, so this graph will help us to understand and maintain the things in Cred app. So this is an example how the entities and the attributes works in managing the databases. So this is an example. Thank you. So I conclude this presentation.